Okay, I think this is live. Great. Okay, so let's wait 1 minute to start. I think this is live. Let's wait and see. Mm-hmm. Oh, yeah. Okay, welcome. Good morning today. Everything's okay. Okay, that's amazing. Hopefully everything's okay. Okay, I think we can start in 1 minute if you'd like. My cat is also ready. I'm not sure where she is, but I think my cat is also ready. Okay, so a lot of people are joining. Welcome, everyone. I think we can start in 1 minute. Hello, good morning, everyone. So I think this is a good place to start. Welcome, everyone who's joined. Thank you all for being here on a Saturday. This is going to be a virtual event. So in previous years, some time ago, this was in person with, of course, amazing Greek foods. But I think that this time it has to be remote. So all I get is Portuguese food, and it's also not that bad. So I am here in the corner of Europe. So on this side of Europe, which is the extreme side of the European Union, and you are in the other sides of the European Union. Still very interesting, but let's start this session and do something interesting with Cosmos DB. Okay, thank you very much. Thank you for joining us as well. Really glad to be here, but hopefully next time I'll be there in person. So let's get the session started. I actually have a thing here for this, so we can start this. And you probably remember that some time ago, last year, I was there delivering a session about SQL curiosities, Curiosity Killed the Cat. This is one of my best experiences delivering a session because I went around a lot of Greek islands to take photos of cats before doing the session. So this was very amazing. And of course, I couldn't forget that session. Of all of the times that I've delivered that session, this was probably the most fun one that I've had. Anyway, welcome everyone. This is going to be a very fantastic documentary. We are going to talk about Cosmos DB, an amazing product that's out in the wild at this moment, somewhere in the clouds. We are going to talk about this amazing product that can do wonders with nature. It can reproduce itself with all of the regions in Azure. It's an amazing product, but we'll have a look, of course. So welcome everyone in Greece and everywhere around the world. We are going to do this amazing documentary on this fantastic technology. And of course, my name is André Melancia. I'm doing this crazy documentary from home in Portugal. And of course, I'm being met with my fantastic cats, which every time I do a documentary about Azure, she also shows up. So this is, of course, my Azure demo cats. She does a lot of cats things, but let's try to do this in a better way at this moment. Okay, so once again, welcome. Glad to have you all here. This was just a very strange beginning to a session. Probably the first time you heard someone do some crazy speaking like this in a technical conference. But if we are all at home, we have to do some crazy things, otherwise we'll just go crazy. And let's try to do something interesting in terms of Cosmos DB. So a lot of people joining. Let me just say that if you have any questions, feel free to ask in the chat. Really happy that everyone is here on a crazy Saturday, and please ask any questions. My cat will also try to answer those questions as well. And let's have a look. So first of all, before we begin, let me just say that we are not alone. We have cats. My cat insists on being here, so that's fine. And we are not alone. We have a lot of aliens joining us and putting up monoliths. This is amazing. And you can see this kind of monoliths all over the world. You can see them in Australia, in Romania, even in the United States, of course. And this is a capitalist monolith. And of course, somewhere in the beach in Portugal, in Greece, we also have interesting monoliths, which are quite amazing. But now let's have a look at important things. I can't get rid of my cat. My cat is here, so I can't get rid of her. But that's okay. We'll try to do demos like this. And first of all, thank you to all of the sponsors. This is very important to have so many sponsors being able to help this event with so many contributions. Hopefully next time we'll be able to meet in person. And of course, do get in touch with these sponsors. They will have a lot of things to offer you. And let's move on to the actual session. So first of all, this is Cosmos DB in the natural surroundings. So first of all, this is a NoSQL database. Cosmos DB is, of course, able to store information up to petabytes of information using NoSQL. So if you haven't seen NoSQL databases, if you are used to SQL databases, this is, of course, very simple to use. And we'll of course try to show you a lot of examples using this. Most of the examples we'll see will be with JSON format, so you can use JSON to store the information. So as many fields as you'd like, but using JSON. We'll do some small examples, but the size of each records or document, if you prefer, can be quite big. So, of course, Cosmos DB is amazing. It's quick like a gazelle jumping through the jungle, as they say. And that means that you can have one specific location in one place to run this, but then at the same time, you can have a lot of different regions all over the world to have a copy of that information. And you can have one copy that's used for reading and writing, and you can have a whole bunch of copies that are used for just reading. But if you prefer, there's a configuration option that all of them can be used for reading and all of them can be used for writing. In that case, you might have some conflicts. And if that's the case, it's perfectly okay. We can always try to resolve some conflicts, and there is options to resolve conflicts if that goes and happens. Okay, so as I mentioned, globally replicated, multi-master, read-write, etc. So this is amazing. It's quite quick as well. So in terms of speed, it's much faster than a SQL database. So let's say you have some information coming in from, let's say, an IoT device like a okay, like a Raspberry Pi, something like that, and you can get the information coming in as fast as possible and store the information immediately. If it is a SQL database, you have some transactional issues, some ACID properties, etc., that require you to spend a bit of time before you're able to store any kind of records. But here it's much faster because all of this is simplified, so it is much faster. Anyway, there are multiple APIs, and let's spend 1 or 2 minutes just discussing all of the APIs that are available. For demos, I will use the first one, but all of these are currently available, and in the future, a few more might be available as well. So first of all, you have the Core SQL API. This is named core/SQL. That means that you can do your queries using SQL language. You can also use them using REST APIs. There's also an SDK for this as well. And this was what was previously called DocumentDB. You probably heard of DocumentDB in Azure. This was fairly simple to use. So you could use DocumentDB before. Now we'll talk about this a bit more. These are simple. These are simple NoSQL containers where you can store as many records as you want, up to petabytes of records, and each record can have a very big size, even attachments, etc. But in most cases, you just store a few records. Not that necessarily big size, but it's entirely up to you. Once you write a record to a region, that will replicate to all of the regions around the world. So that's very simple. And there's also a few other APIs as well, which also have the same behavior, of course. So one of them is something called Table API. And this is when you need to migrate something called Azure Storage Table. So you have your Azure storage that typically stores files, etc. But you can also use that to store a NoSQL table. And this is very basic. Not that much indexing going on, so very simple. But if you want to scale it up to a lot of capacity, etc., in that case, it's a good idea to migrate this to Cosmos DB. So what's the advantage of migrating to Cosmos DB? Well, it's more expensive. That's the downside of it. But at the same time, it's more flexible because you can have a lot more indexing going on in those tables in that case. And at the same time, you can globally replicate this all over the world with that information. While doing that, let's say you have an application that used to use Azure Storage Tables. When you migrate to Table API in Cosmos DB, that means that all of the calls that you have from inside the application, all of the SDK that was used, continues to be used exactly the way it is. There is no change. The only small thing you need to change is the connection string. So no changes into the application, just a change to the connection string. You stop pointing at the Azure Storage Tables and you start pointing at the Cosmos DB. Very simple. Anyway, you also have the MongoDB API, you have the Cassandra API, and you also have a Gremlin compatible API. And that means that, let's say you have a MongoDB somewhere, let's say on premises, somewhere else, and then you can migrate all of the information. We'll see how this is done at the end of the session. You can migrate all of this information into Cosmos DB, guarantee that this is globally replicated as well to whatever level you would like. And at the same time, this is fully managed by Microsoft, so you never have to worry about the infrastructure ever again. Okay, all you have is a wizard, you have the Azure portal, you handle anything from there, and it makes it very simple. Anyway, you also have, as I mentioned, MongoDB and Cassandra API. Both of these will be very simple. To use, of course, and you can also use Gremlin API. All the first four are normal NoSQL databases, and in that case, the first four can just use the same APIs as before. So DocumentDB API for core SQL, Azure Storage Tables for Table API, and then Mongo and Cassandra respective connections for each of these. With Gremlin, you can also use any Gremlin compatible driver, but Gremlin is slightly different than everything else. And the reason for this is that Gremlin will actually use not a table with records, but actually nodes that point to some other place. So let's get an example of this. Let's say we have a map here of Europe behind me, and let's say I'm here, so we point Lisbon here all the way to Madrid, all the way to Paris, all the way to Athens, etc. So you can have all of the cities interconnected using Gremlin API. You have a node for each city, and then you have an edge for all of the paths that are possible, and then you can take the information and do any kind of operations to detect which is the best route to go from Lisbon all of the way to Athens and things like that. So it's very flexible, but it's great for using graphs, not for using NoSQL normal, let's call them normal data. But all of the first four are just for normal NoSQL databases. As I mentioned, the last one is for graphs. So again, very, very simple to use. Okay, this is the last slide that I have for you. All of the rest is going to be demos. Okay, and I have my cat here that seems to want to play around with demos as well. So let's have a look at this while I have my cat here. I cannot get rid of her, so let's try to do the demo at the same time. No problem. When she heard about cats in Greece, I think she was very curious. She wants to take this as a dating webcast for her, something like that. So before we start, let me just mention that we have Azure.com. So if you don't have Azure, you don't need to worry. You can get it for free. And every time anyone hears the word free, this is always most interesting. Okay, so let's have a look at Azure, and you start in Azure.com, you say start for free, and suddenly all you have to do is fill in all of the information. Again, here, start for free, fill in all of the information, and you have free credit for a whole month. 170 euros of credit for a whole month. And then for the next 12 months, you also have some free products that you can use. So you don't have to pay for this. The idea here is that you are able to learn all of these technologies, Cosmos DB and any other technology in Azure, and you don't have to worry about payment. This is always a setback whenever you are trying to learn a technology and they tell you you have to pay for it. No, it's not pleasant to pay for it, so you can get it for free and you can try it. Now, with Cosmos DB, you actually have a free account. If you specify the smallest possible number of request units, which is 400, you actually get it for free. So give it a try. We can use it for free for as long as you'd like, and this way it's completely free. You can try it and prepare your applications. And then when you go into production, then you have to pay for it. Okay, but you can get the Azure account for free, and then once you have your Azure account, you can go to portal.azure.com. I already have my portal here with all of the things, so I have a lot of virtual machines, some cognitive services, etc. So quite a few number of things. And down here, I have my SQL databases, I have machine learning, etc. Synapse Analytics, which is very famous at this moment. It just came out of preview. And I have, of course, my Cosmos DB. So let me go here to Cosmos DB. If you click this, you'll go into something here, and this is your Cosmos DB account. And a bit of information. I'm running this in West Europe, but also a copy in North Europe. But how did I get here? So let's first figure out how I got here to create a Cosmos DB account. So first of all, you start at the portal and you say plus sign. And then typically there's something that says Cosmos DB down here. My cat is in the way, but that's okay. And Cosmos DB here. And you can go here and then you have to specify a resource group. So let's have a look. Let me go to resource group IT Pro Dev, and then account name. Wait a minute, let me try this. So cat again by cat. Okay, I really need two hands to do this at this point. Okay, so let me say Andy my. Oh wait a minute, Andy my cat Cosmos demo. Okay. So let's call it like that. And then I have some APIs, as I mentioned. You have the core SQL, you have the MongoDB, you have the Cassandra, Azure Tables, and you have the Gremlin API. We'll use the core SQL. You also have notebooks. So nowadays you can even have notebooks inside of the Cosmos DB Explorer and play around with notebooks as well. This is very powerful. And then you have to specify the location. I think that in the future you will have a region for Azure close to you. But at this point, I usually recommend West Europe. It's probably one of the best regions to work with all of this. It's the region that includes pretty much all of the Azure services. So I do recommend that in most cases. Then you have the capacity mode. Now this is interesting. You have to specify if you want provisioned or serverless. So provisioned, that means that you are paying every hour for a specific capacity that you specify. The minimum is 400 request units. The maximum is quite big and very expensive. But that means that you can store up to petabytes of information and get a lot of different interaction very quickly with all of those petabytes of information. If it is provisioned, as I mentioned, it's always running. If it is serverless, that means that it's only running when you do a query. So if you are using this maybe once a day to process information, that's fine. If you are receiving things from any kind of IoT device, any kind of thing that sends things all of the time, in that case, serverless will not be good for you because basically you can never turn it off. It's always running because someone is always sending information to you. This is great if this is part of some ETL process once a day, for instance, at night or something like that. Serverless is probably good. If you're running this continuously, just use the provisions. You also have the possibility of, if you have a peak hour where you use a lot of it, you can increase the capacity, but then during the rest of the day, you have a smaller capacity. So you can script these changes and run them any way you want. This is very, very simple. Anyway, you also have a few other options. One of the options is to apply the free tier discount. This is grayed out. I'm not allowed to do this. Why? Because I already have a Cosmos DB account that I created before, and this one is free. Okay, this one was free for me, so I enabled the discount, and I can only have one discount at a time. This makes sense, of course, but if this is for you, just try this with the free tier discount enabled, because you will always get something free. So that's a bit better. Remember that the maximum for free is 400 request units. That's your limit, and you get up to 5 gigabytes of storage for free, but still quite good. So play around with it; it's better. So account type, production or non-production. If you're just playing around with things, just choose non-production. It's a bit better. And then you have a few options for redundancy and for multi-region, etc. So geo-redundancy guarantees that you don't have things just in West Europe. You also have a copy in a different region around the world. You can choose as many regions as you want from the map. We'll see that just in a second. And you also have the possibility of using multi-region rights. So what is that? So in this case, let's say I disable this. So that means my West Europe region has reads and writes. So every time I need to write something, it always has to point to West Europe. But then if I say multi-region rights, that means that everywhere around the world, you can read and write to all of the locations, which makes it much easier to do. Anyway, you also have availability zones. That means that inside of an Azure data center, let's say West Europe, there's actually two different data centers inside, in two locations, actually a bit far away from each other, quite a few kilometers away from each other. And in that case, you'll have a copy in the two data centers for redundancy. This is just great for redundancy. It doesn't give you any extra functionality. It's just redundant in case of disaster scenarios. But let's say disable. And then let's have a look at the other options. So let's say networking, okay? And networking guarantees that you can say that Cosmos DB will be accessible for everywhere around the world. And this is the all networks option. You also have a few other options. For the demo, I always recommend that you have all networks so that you don't have issues with firewalls while you're playing around with Cosmos DB. However, if you are using this in production, you shouldn't use all networks. You should protect this inside of a virtual network inside of Azure. So in this case, you say selected networks, but then you define virtual networks that you want. Let's say a virtual network. Let's say I had a virtual network here. I could select the subnets, and then this will be available inside that subnets, etc. And then you could allow just all of the services inside that subnet to access it. If you're not sure what a subnet is, what a virtual network is, it's the same as a VLAN that you have on premises. So it's a completely isolated location that you have the possibility of using completely isolated, and then you permit things from in and out, and that's just you have to specify it manually. So that's one of the best options for you to prevent people from accessing that. Anyway, you also have private endpoints that allow you to go directly from, let's say, a website directly to your Cosmos DB without any kind of firewall rules. That's very easy. You also have some backup policy as well. So you have some backup policy here that allows you to do any number of backups on a regular basis. This one is every 4 hours, but you can do every 60 minutes, so that's a bit less. And you can go all the way up to backup copies up to 30 days. So that means you get 720 copies. And remember that the copies also cost a bit of money. It's the same pricing as Azure Storage, slightly more expensive, like 10% more expensive, something like that, but it's not that bad. So you can store all of the information here. Remember that if you have petabytes of information, that can be a bit bad. In that case, you will pay a lot of money for that storage. You also have encryption, so you can encrypt it normally, or you can encrypt it using your own key. In that case, you will need a key vault to store that key, but let's skip that part for now. This is the same, by the way. Networking and encryption is the same as most Azure services. And then in the end, you just say review and create, and then you can just say create. By the way, validation failed. I probably missed something along the way. Don't worry. I'm not really going to create it because this will take about 20 minutes to create. But in my case, I've already created one, so this is easy enough. We can go here to Cosmos DB and have it already created. Of course, this is a live session. If I try to create this live, it will spend the next 20 minutes trying to do it. Now, here you have some options. One of the features which is interesting is the Synapse link. So the Synapse Analytics, you can connect to Synapse Analytics using this. Very interesting to do. If we have time, we can try to do this. And then we can say replicate data globally. Now, let's say I want to copy somewhere here in Germany, West Central, or here, United Arab Emirates. Let's say this one. Let's say India, for instance, and then Australia. So I get a copy in all of this, okay? And maybe in Brazil, something like that. So that means that I can just click the map and add some regions to this. Not all of the current Azure regions are available for you to use with Cosmos DB. It's around 20 at this moment. And some of these which are currently with white color here, they are a bit flooded, so that means that you cannot use them currently as a copy for this. And this is something that came along with all of the virus and things like that. Some of these regions became close to their capacity, so that means that they remove some of the services so that they can optimize other services. And Cosmos DB, in this case, which used to be available down here, for instance, for South Africa, stopped being available because they didn't have enough capacity to do this. Most of Europe is not really a problem. This one here you see on top, which is Norway, is just a new region, so it's not really up to the normal capacity because it's completely new. But for all regions like in India and in South Africa, these are currently with a lot of usage, so they have a problem. Now, of course, you can just say that all of these regions are reads and writes. This is how I created it. But let's say disable. Okay. If I say disable, that means that my West Europe region will be my write regions. By the way, I currently have 2, but if I then change this and save this will change. And then I have some read regions that I can add. Okay, it's actually a bug in the interface because there's supposed to be only one. But in any case, I can change whatever I want. Let's say enable, disable, etc. The rights for the first region or for all of the regions. And then you click save. And when you click save, this will copy the information to the other new regions. So let's say that I'm using this in West Europe and North Europe, and I want to get rid of North Europe. I can just unclick North Europe from here, and suddenly this will just go to the other ones. The best option to do this is first duplicate to the new regions, and then once the information is duplicated, remove the old regions. That's usually the best scenario that guarantees redundancy. You don't want to have everything in just one region and then delete all of the other regions and then start copying to the new regions. If there's a calamity during that time, you will lose all of your data, of course, right? So first of all, copy to the new ones. Once you have the things copied, remove the old regions you don't want. And you can change this at any time. If you don't like the things at any time, you can just change them. And that's of course very easy. Now you also have something, okay, so you also have something which is called default consistency. Let me explain this quickly. So let's say that you have a records, and let's say my application, I want to write a records to a Cosmos DB, and when I write that record, let's say I'm writing to West Europe. If I write it to West Europe, that means that I submit the requests. And then if I'm using strong, they will send the requests to my region. My region will write it. It will send to all of the other regions. Those regions will write it. And then it comes back to my application saying strong. Okay, everything's updated. I'm happy. It's like a SQL transaction. Well, it's not, but it feels like a SQL transaction because you know everything's okay around the world with the information that you updated. So you have some guarantee that things are consistent. Okay. However, if you go to the opposite one, this is great for ETL. The eventual is great. For not ETL, for IoT. This is great for IoT devices, etc., in which you receive a sample from an IoT device, so you immediately send it to Cosmos DB. But if you try to read it in the same region that you send the eventual, you might not be able to see the record. It might not be written yet, even on the region where you are, because this goes into a queue, and then that queue will save the records. That means that it will come back to your application very quickly. You write the record and it comes back almost immediately. But at the same time, around the world, so in that region and around the world, whenever they have the chance, eventually, like the name says, they will write to that region. So after a few seconds, it will be written. You can do selects and see the records once it's written, but there is no guarantee that the record will be written even to your region. Now, to fix this problem, because some applications expect to write things and do a select with all of the information immediately, you can have the session. So the session guarantees that you write a record to your region. It waits until your region finishes writing the record on itself, and then it will propagate to other regions, but at the same time, it will return to your application saying, at least my region already wrote this. The other regions will eventually write this as well. Okay, so in that case, this works really well because you can guarantee that at least for your reads and writes, you look like a consistent database. Okay, but for other regions around the world, it might take a few seconds. So you have everyone else has to wait for a bit, and then you have some others in the middle which have a bit more and a bit less things. Feel free to have a look at the documentation in docs.microsoft.com for the exact details. But for our point of view, it's just important to know about the strong, the session, and the eventual consistency. All of the others are somewhere in the middle. And then, of course, you have backups and restores. This is easy. We talked about this before. Firewalls, virtual networks, you can play around with this here. Selected networks and use them. Private endpoints, so connection directly from A to B. If you are a website, you connect directly to the Cosmos DB without caring about firewalls in the middle. It's like a physical direct cable that you connect from A to B. Very practical. You also have some keys. This is important. So you have some keys that you are going to use. And in my case, I need to use one of these keys. So let me just copy this to the clipboard. I might need to use this this later on. And then, of course, you have some other options, security, etc. And, of course, you have containers. You can scale all of this, but we'll have a look at this back in the overview. Once you get started, and this is how you get started, you can press here to add a container, okay? Or you can go here to your Data Explorer and see everything from here. This is probably the best place to see this, so let's have a look here. And I've already created a database. So in my case, I have a database called SampleDB because I pressed this button here, okay? And that created a database. That's as simple as that. It actually created a persons table. Sadly, the items didn't get copied for some weird bug. Last week they got copied. Today they didn't get copied for some strange reason, but that's okay. So I created a person's table. I can also create a new one. So let's say I want to create a new container. By the way, a container is like, it's like a table, okay? So let's say new container. And let's say that I can create a new database if I want to, and give it whatever name, sample database 2 something, or I can just use an existing database, and in that case, I'll use the SampleDB one that I have here. I can just reuse it. There's no point at this point to show you this, but a database is similar to a SQL database. Let's have a look at the slide that explains this very quickly. So this is the naming differences with different APIs. Of course, you have the core SQL, you have the Mongo, the Cassandra, the Azure tables, etc. So on top, you always have a database account, which is of a specific type. Our type is that account that you saw in the Azure portal, which was core SQL, and then inside you have one or more databases. This is the same as having a SQL Server instance on top and then multiple databases immediately after. And then you have containers which are basically tables, okay? Except for the other ones which are graphs. In most cases, you can think of this as tables, okay? And then each table will have specific records or items. So, these tables can be called slightly different names depending on the API. So you can call them tables if you want to. You can call them containers. You can call them collections. Or if this is, of course, Gremlin API, you can call them a graph. It's actually a connected graph, etc. But there's more APIs in the future, so there might be other names. Each item individual, so each record individually, will have a specific name, so you can call them items. You can also call them documents. DocumentDB used to call them documents, but nowadays they just call them items. It's easier to understand, but you can call them records if you prefer, or rows. Rows is not very good, but you can call them records if you want to. So document, row, nodes, edges. So these two nodes and edges are actually just for the graph. So you have the nodes, like the name of a city, etc. And then you have the edges that connect the roads that connect these cities, etc. That are slightly different. Anyway, each table, and remember that this is slightly different than a normal SQL database. Each table will have store procedures, and these are just specific for that table context. It has store procedures and user-defined functions. These are very similar to the ones you would expect for SQL. However, please bear in mind that these are programmed not in T-SQL, but actually in JavaScript. Okay, so store procedures, user-defined functions, and triggers are programmed. Depends of course on the API, but basically in the core SQL we are using JavaScript to do this. You also have the possibility of handling conflicts, and of course you have store procedures that handle merge procedures. So let's say that you write to the same records in two different places, and then you have to decide which of the records you want to keep. In most cases, the default is choosing by the time. So that means the most recent one wins. But you can also define this by any merge procedure that actually decides which of the two you want to keep. You can even keep parts of one, parts of the other, etc. So you have to decide which procedure and write that in code to handle this. Anyway, let's go back to the demo. And now that we know the naming of the things, I can still call them tables and records, perfectly acceptable. Okay, let's say container ID. So let's say person table. Okay, let's actually call it person table 2. And then partition key. The partition key is basically, you typically have an ID. The ID is the unique primary key of the thing, but then you also have a partition key. So what's the partition key? Let's say that you have just small amount of data. You don't really need a partition key. Everything is in the same physical nodes that the information is stored. But then if you have a lot of data, one physical node is not enough to store terabytes or petabytes of information. In that case, you need to divide the information into multiple physical nodes. So in that case, you partition the information by nodes, and then you have a partition key so that you can hash the information, and the information that's related, let's say, to the same client can stay in the same partition. So if you say client ID here, let's say client ID, in that case, all of the information from the same client stays in the same partition, okay? In this case, please bear in mind one thing, because this is a JSON format. So JSON format expects that uppercase and lowercase is going to be exactly this different things. So if you say client ID like this or client ID like this, these are two different fields. Okay, so please be careful of this. That's usually the error that most people do. Make sure that this is, if it is all lowercase, make sure you then write code which is exactly the same, because this will fail. In my case, if I have just sequential IDs and I don't have any specific way to divide the information, you can just say /ID. This will be reasonable to divide all of the information into multiple partitions if you have them. And by the way, the division into multiple partitions is not your problem. This is done automatically for you. You don't see it, you don't care, things just work, okay? So here, anyway, minimum capacity, oh, this is weird, okay. Okay, this is strange. Okay, so minimum capacity here, 400 request units. You can go all the way up to a much bigger value of 100,000. Let me just see the pricing. So the pricing for this one is 20 cents per hour, but the pricing for the maximum one, just out of curiosity, which is 100,000, will cost around 35,000 euros per month. But then again, this is petabytes of information, right? But in our case, let's keep the 400, and it's actually free. Although it's 140 euros per month, this should actually be free in the first, if you use the free tier, okay? But be careful, because the free tier doesn't support multiple regions, so you have to pay that separately. And remember that I have this in multiple regions already. Okay, but anyway, this is an estimate, 2 regions, etc., 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 and the cost is an estimate. Analytical data store, so this means that you can connect this to Synapse Analytics, and there's going to be sessions about Synapse. So you'll probably be able to see this and just import the information into Synapse. And then you can even add unique keys. So this is the same as unique keys in SQL. You can add other fields which are supposed to be unique as well and validate that constraint. But at this moment, let's just say okay. So I add a new table here. And I can just add 1 or 2 records. So we have about 5 minutes to go. So I think this will be plenty of time to do this. So let's say records, and then we have my persons table number 2. Let's go to items. This is empty. You have your ID, which is the primary key, and you have the /ID, still the same ID, but the slash just tells you the path for all of the things, because this can be hierarchical inside. This can be a zip code, something else, but the ID here is actually the partition. In our case, both of these are the same, but let's say I want to create a new item for a person, and let's say ID is going to be person 1. So let's say ID is equal to 1, and then let's say name, and then let's say person 1, and then let's just add the age. Okay, age is about 4 years old. Okay, that's all right. Okay, so I can add this as 4 years old, save this record, and then you get added a few extra things. These two are the record ID and the record ID again, but with the ID of your table or collection and the ID of your database. eTag just guarantees that if you change the information, the eTag will also change. This is similar to the eTag that you have in HTTP and HTTPS. You can have attachments, and you have a timestamp that tells you when you updated the record. So again, very simple. Let's just create a new item again. So let me just add here a new item. So you can have, let's say, person 2, age, let's say 40 in this case. But then I can add an extra field, and then say something, okay? And then add that extra field. So I can save it. I can even add a new one, but you get the point. So let's say I want a new SQL query. I just execute the query. You might find it strange that it selects star from C. What's C? Okay. But now you have all of the records here. You can specify individual values. So you can say, let's say C dot ID, C dot name only. Okay. Actually, let's put in as age. Age is better. Let's add C name, C.age, okay? And then we can execute it and then just have this information, not the other fields that are there. But in any case, you can do wheres, etc. So all of this is very easy, but be careful because the wheres actually use double quotes, okay? So small difference here. In any case, you can run any query you'd like. This is not that much different from the SQL syntax except for the double quotes, etc., and maybe a few others. You also have stored procedures, so you can add your own stored procedures to this. You can add user-defined functions. Let me try to create one for you. Okay, let's say a user-defined function. Okay, let me just copy-paste because we don't have that much time. So in my case, I will actually copy-paste a function that I've created here before for age. Okay, so I have a function called age group. Okay, create function. Let's say function. Oh, sorry. This is not properly copied. Okay, so let's say copy pastes. This is live, so errors are bound to happen. Okay, so let's call it age group. Okay, and then save the function. So hopefully this is okay, and this should work. So if age is less than 3, it's a baby, a child, teenager, adult, etc. So this is all okay. And then let's go here and say age, and then say age group of c.age. Okay. And then execute the query. Oh, okay. Age group is okay, right? Okay, so user-defined function is okay. Let's try this again. Execute query as X. Okay. So some error. Oh yeah, of course. My fault. User-defined function dot age group. That's what I'm missing, okay? So I have here child, adult, etc. So this just works. You do have to have a prefix like that. By the way, if you just say ID without the C, that will also fail, okay? Because they expect you to do the prefix so the things are explicit. By the way, the reason you can just say from C and not actually specify a table is that the context where this query runs is not the database context. It's actually that specific container or table context, okay? This is something that comes along historically. So you can just say, if you want to, you can just say person table to as C. It's exactly the same thing, but you don't need it. Okay, you get the exact same thing. Now, we are already running out of time. Let me just do a quick demo about how to import data. And you have something called the Cosmos DB data migration tool. Let me just add some files into this. And these files are the solarsystem.json files, and these have the names of the planets, etc., name of the planet, distance from the sun, etc. So these are fairly simple to do. Okay, I'm gonna copy the next one, and then I need a connection string. By the way, the connection string is the one that I got before, but I need to add database is equal to something. Okay, before this or after this doesn't really matter, but you do have to add the database. It's important. This verifies if it's all okay, that's fine. Let's say live planets collection or table. Okay, let's call it like this. And then partition key, etc. I'm just going to leave this blank. I don't want to care. Okay, so this is going to run. So all of the defaults, I'm not going to change anything, just the defaults. And this will take a few seconds. So my content is actually very simple. So all was transferred okay. And let's have a look at the results for all of this specifically. Okay, so let's say notepads. And first of all, let's go here to notepads and see what I have here specifically. And see the actual result file open. And then 1 second, you have this going on here. So you have name, distance, etc. I don't have an ID, by the way. Okay, there is no ID. Okay, we are definitely running out of time. 1 second, let me just finish this. No ID, so this will be generated automatically. So if you refresh here, you should now have all of the information coming up here. So you have some live planets table here. Let's go to items. And then let's have a look at the items here. So the ID is generated automatically. Let's do a query and execute the query. Now you have distance, name, etc., volume. This was what we had before. And then ID was generated automatically and the rest of the other ones as well. But the ID is still the ID. It's still the primary key. Some of these have more fields than others. So distance from the sun, etc. Some of these have more things than others. One of them, for instance, has a comment, which is of course something that you can add on a NoSQL database, but still very interesting. Just to finish this off, we have also some settings, and as I mentioned, you can scale this as much as you want. Some additional settings for time to live, so the records can be created or destroyed. You can create them with a timeout. So after X number of hours or something like that, you can just say, please delete the records after 3 hours. So if you say 3,600, that means that after 1 hour, the time to live will be destroyed. But you can configure this by each individual record if you want to, or just specify a default for all of the table. You also have indexing, which is by default automatically, but you can do this manually. And finally, of course, you have conflict resolution, and the timestamp is usually the default, but you can even have a merge procedure and specify the store procedure yourself so that you control this with code by yourself. Final one, just very, very quickly. We're definitely running out of time. If you are using Synapse Analytics, and I won't have time to do that much of a demo here, but if you are using Synapse Analytics, let me just go and show you that you can actually get this from there. So if you go to Synapse Analytics Studio, you can actually see those informations there. So you enter the Synapse Analytics Studio, you go on the left to the data thing, and one second, this is very, very slow, of course. By the way, if anyone has any questions, feel free to ask in the chats. We still have a few seconds. I can definitely answer that. If not, of course, you can ask me later, no problem. So let's say you go here to data, linked, and linked, I already have a Cosmos DB here. And inside of that Cosmos DB, you can link it by pressing the plus sign, of course. And here you have my live planets table, which should have some information, my person table here as well. And then you can say new SQL script, select top 100 records. Let's try the person table here. And then in this case, I need to add the key. So let's go and add the key itself very quickly. Let's add the key. So copy the key. You can use just a read-only key. That would be fine. But let me just add the read-write key. It's indifferent, but that's okay. And then paste this and then run this. Hopefully this will be okay. So you can run this, select, oh, okay, my fault. I selected something bad. So run. So select top something from open row sets, and then this will give you the result, but in a real SQL world, which is your SQL server style environment that you have here. So if you don't like the Cosmos DB, you can always have this here. So in this case, of course, you have person 1, person 2 showing up here, age, extra field, etc. So you can play around with this. And of course, it's very easy. This is Synapse Analytics. You probably have some sessions about Synapse Analytics. I do recommend that you have a look. These are quite good, and they became general availability last week. So feel free to have a look. Anyway, this is all of the session that we have. Some useful links. docs.microsoft.com has all of the information that you need. Microsoft.com/learn has a few learning paths for you to get started with Cosmos DB. If you go to Microsoft Learning on GitHub, you select a repository called DP200, and there's going to be a lab, which is lab number 5, lab number 4, that is, which has information about Cosmos DB. You can try it. And finally, you have the Azure.com/pricing. You never want to go there, but you probably will have to go there. Anyway, having said that, if there are any questions, feel free to ask. I know that this is not in person, sadly, and I would really love to be in person to actually interact with everyone and get some amazing Greek foods like the years before. But this year, sadly, this is not going to happen. But in any case, feel free to ask in the chats. Anyway, thank you all for being here. It's really great to be presenting a session for Greece again. Hopefully next time this is in person, and stay safe. Feel free to ask any questions at any time on LinkedIn or on social networks. Okay. So thank you all and have an amazing conference. Thank you all. Okay, thank you very much, Antonius, for having me. Have fun in the events, and stay safe, everyone.